We are live. Hi everyone, welcome back to Geeks for Geeks practice. Today we will be discussing the problem of the day for 18th of December. That is maximum difference between node and its ancestor. This is a medium level problem and the accuracy for this problem is 34%, and the number of submissions for this problem are 43,000 plus. The number of points awarded for this problem are 4, and this problem has been asked previously in Amazon. So just quickly give me a +1 in the chat if if my screen is visible to everyone and I am audible to everyone, and then immediately we'll begin with the session. I'll just wait for a couple of minutes for everyone else to join in, and then we'll start with the session today. So all those who have joined the session, please quickly give me a +1 in the chat so that I know that everything is working fine, and once everyone else joins in, so we'll start with the session today. This is a good problem. It's a medium level problem. It can be done using BFS as well as DFS. First of all, we'll be discussing the DFS approach. Then we'll also be discussing the BFS approach, and I'll be showing you the code for both. As you can see, these are the codes for both that I have got accepted. And how many of you were able to solve this problem? Just quickly comment down below. I just wanted to know how many of you were able to solve this problem. Hi Chirag. Okay, right. So I'll just wait for one more minute for everyone else to join in, and then we'll begin with this problem. So as you know, this problem has been previously asked in Amazon. So you can see that Amazon or companies like that asks a lot of questions based on trees or binary trees or BSTs, right? So these are important topics that you need to practice. That is why you should daily be solving this POD, that is problem of the day, on Geeks for Geeks. So let's read the problem statement now. So the problem says that the maximum difference between, you have to find the maximum difference between the node and its ancestor, right? So it says that you have been given a binary tree and you need to find the maximum value which you can get by subtracting the value of a node B from a node A, where A and B are two nodes of a given binary tree and A is ancestor of B, right? So if A is ancestor of B, that means either A is a parent of B or A can be grandparent or something like that, right? So basically A will be occurring if there is a path from that contains A and B both, then in that path A will be occurring before B, right? You can understand it this way as well. So let me show you for this example 5, 2 and 1. So if the case is 5, 2 and 1, you have to find the maximum difference between the parent and the child, right? So what you have to do is, let's say this is 5, this is 2 and this is 1, right? So what happens in this case is you have to find the maximum difference. You have to find the maximum difference between node and its ancestor, right? Let's say, what is the ancestor of this? So for this 2, the ancestor, its ancestor is 5, right? All the nodes which are there in the path from A to B, such that, let's say if this is a tree, let me make it. Let's say if this is a tree, then in that case you will say, according to this question, you will say that this is for this particular node, this is also an ancestor, this is also an ancestor for this particular node, right? If this is the node, then for this particular node, this is the ancestor and this is the ancestor as well, right? So this is what it means by ancestor. Basically the node which is having the path from A, which is having A and B both in it, and A is occurring before B, right? So all those are considered as ancestors. Now let's say if you are given this tree, so in this case you can see that for this tree, what is the ancestor? The ancestor or the parent is this node, right? So since 5 is the parent node, so what will happen in this case? You can see that for 5 there is a child 1. So what is the difference? This is 5 is A is equal to 5 and B is equal to 1, right? If let's say I'm looking at this, right? So what will happen in this case? You can see that the difference between the two is 4, right? What is the difference between this and this? 5 and 2. If A is 5 and B is 2, then the difference is 5 minus 2, that is 3, right? So for this A and B, the difference is coming out to be 3, and for this A and B, the difference is coming out to be 1, right? So that is the difference is coming out to be 4. So which is the maximum difference? The maximum difference is 4, right? So you will print 4 for this case. But wait, is it clear from this test case? No, nothing such is clear. One more thing that you need to notice in this problem is, that let's say if you have been given only one node, right? If you have been given only one node, or if you have been given no node, right? If there is only one node, that is, let's say this node, let's say it is 10, so in that case there is no answer, right? Why? Because for this case you can see that for this case the answer is because there are, you need at least two nodes, right? There should have been a node like this, let's say 50 or something like that, so that you could have returned some answer. For this the answer will be -5, that is 10 minus 15, that is -5. But for this node 10, there is no ancestor or ancestor or descendant kind of relationship, right? So this is what you need to do in this question. Now just quickly let me know in the comments, is this question clear to everyone? Is the basic part of the question clear to everyone? I'll be taking a bigger test case as well. Let me take the second test case that has been given to us. So the second test case is this: 1, 2, 3 and 7, right? So let's say if the tree given to us is 1, then 2, then 3 and then 7, right? Let me verify again. So 1, 2, then 3 and 7, right? So if this is the tree that has been given to us, so in this case what you will do is you will always try to, how will you find the answer, right? Let's say there is an ancestor A and there is B descendant, right? So if let's say your ancestor is fixed, right? So in that case you will try to minimize the value of B, right? If you say that A is fixed, then what will be the value of B? The value of B should be as minimum as possible. If the value of B is minimum, then in that case my answer can maximize, right? If B is minimum, can I say that if B is minimum for a particular given A, if B is minimum, then can I say that my answer can maximize, right? This difference A minus B can be maximized, right? I can say this. How? So let's say you are at this node, so every time what you will be doing is, every node of the tree will be giving you the minimum that is up till there, right? So for this node you come to this node and you start your traversal. So you see that for this node initially you will be marking your answer, initially you will be marking your result, that is the final answer that you will be returning result as int underscore min. Why int underscore min? Because you want int underscore min because you want to maximize your answer, right? You want the maximum difference. That is why you will initialize your answer to int underscore min. Then after that what you will do is you go to this tree and you first of all do the DFS traversal of this tree. So what will happen? I go to this tree and I do the DFS traversal. So up till now, can I say that the maximum node that I have seen, minimum node that I have seen up till now is nothing but 1? Can I say this? Yes, I can say this, right? The minimum node that I have seen up till now is 1, right? Now once I move down, so I see that there are other nodes as well in this tree, right? So you can see that the minimum node that I have seen up till now is 1, but this is the root node, right? So what will happen? Every node will be returning or returning the minimum node that has been seen up till there. So for this node, can I say that 2 is the minimum node that I have seen up till now? Yes. For this node, I can say that 2 is the minimum that I have seen up till now, right? Because below this node there are no children, so that is why 2 will be for this node, right? I go down to this, I see that I go to 7, right? Once I go to 7, so I see that 7 is there, but 7 from this node I will return 7 because up till now the minimum element is 7 in this tree. Now I move up, right? From this DFS call I move up and I see which is the minimum element. So I see that there is no right child. Since there is no right child, so I'll be returning int underscore max. Int underscore max means that I'll be returning a infinity value. I'll be returning something that is infinity. Why? Because since this node doesn't exist, so I do not want any abrupt answer. So I want to return infinity, indicating that there is no node in this, right? So what I'll do after that, I come back here, I see that there is 3. So from this 3, what I'll do, I will say that between 7 and 3 the minimum is 3, right? After this, what will happen? I was at this node, right? So I could see that there were no children. For this node, there is a child 3. So can I say that since this is if A is equal to 3 and B is equal to 7, then A minus B is for this node is -4. So for this node, the A minus B value is nothing but -4, right? Now I move up and I go to this node, right? I go to this node 1. So my A is 1, right? A is 1 and I will see which is the minimum value that I am getting here. Is 2 minimum or 3 minimum? The minimum is 2, right? So I'll assign B as 2. Now what is the difference between A and B? A minus B is equal to nothing but minus 1. Which is lesser between, which is the maximum between minus 1 and minus 4? The maximum is minus 1, right? So that is why from this I'll be returning minus 1, right? Now let me show you another example for this problem and how I'll be approaching it further, right? So let's say if I have been given a bigger tree, let me draw the diagram for it. So the diagram looks like this. The tree looks like this: 8, then 8 is connected to 3, then 3 is connected to, let's say, 10, then 10 is connected to 3 is connected to 1, 3 is connected to 6, then 4, then 7 here, and then this 10 is connected to 14, and this is connected to 13. Just quickly let me know what, I'm giving you 30 seconds, so just quickly let me know what will be the maximum difference between A minus B. What will be the, for this particular test case, what will be the maximum difference between ancestor and descendant, right? Ancestor and child, what will be it? Can someone tell me in the chat? Someone can tell me in the chat? Anyone would like to tell me in the chat? Okay, so I think the live is working fine. Yeah, anyone can tell me in the chat what will be the maximum answer for this? What will be the maximum difference? Also notice one thing, that if I talk about this node, and this node, then this 3 is an ancestor of this 7, right? This 3 is also an ancestor of this 4, this 3 is also ancestor of this 6, right? For this particular case I am asking, what is the maximum difference between A and B that I can obtain? What is the maximum difference between A and B that I can obtain? Every time at each node, what I'll be doing is I'll be storing the minimum up till there, right? The minimum that I've seen up till there. I move down through this recursive call, and I see that up till now, if once I move to the leaf node, right? Yeah, 7 is the answer, right? Once I move to the leaf node, right? So I go there, and I see that there is 1. There is no left child or right child, right? So for this, I'll not be getting any answer, right? So it is nothing but int, you can say int underscore min. So the answer hasn't been gotten up till now, right? Once I move back, So up till here, what is the minimum? Up till 3, what is the minimum element up till 3? Can I say that the minimum element up till 3 is nothing but 1, right? Minimum element up till 3, that is for this 3, up till there the minimum element is 3, right? Because from the left I am getting minimum as 3. I move down, I move towards the right, I see that there is 4. So for this 4, I'll not be having any answer, right? It will give me infinity because it has no children, right? So this will not be any ancestor. This 7 will also not be any ancestor. But for this 6, can I say that for this 6 I'll be getting 4 is the B value, right? B value for this, if for this the B value, the minimum value that I have seen up till here is 4, right? And if I say that A is equal to 6, then B will be 4, so the difference comes out to be 2. Here I am getting the difference 2, right? I am getting a difference of 2 here in this case, right? After this I move up, and the minimum up till here, is nothing but 4, right? The minimum, that is mi, is nothing but 4. The minimum up till here is 1. So I come to this node, and I see that the minimum here is 4 and the minimum here is 1. So can I update my minimum? No, the minimum is 1, so that will remain, right? After this I see that if, let's say, this is A, if A is equal to 3, that is A is this node, right? And if B is what? B is 1, because I was trying to minimize the B. So A minus B will be what? 3 minus 1, that is nothing but 2, right? So I get the answer 2 here as well. Right? Now I move up, I move back, and I go down to this traversal, right? I see that there is 10. So okay, I go down again, I go towards the left, so I did, there is 13. So 13 won't be any ancestor for anyone. So what happens? You move up, you see that what is the minimum element that you have seen up till now? The minimum is nothing but 13. And can I say that if A is equal to 14, right, then B for it will be 13, nothing but 13, because there is no other option. So what is the difference between the two? The difference is nothing but 1. Here the difference comes out to be 1, right? Okay, right. After this, what will happen? I move up again, and I'll say what is the minimum value that I've seen up till now. The minimum is nothing but 13 is still, right? The minimum still is 13. And can I say if my A is equal to 10, then B will be nothing but the minimum element up till now in this subtree, in the lower part, that is nothing but 13. So that means that the difference will come out to be minus 3, right? 10 minus 13, that is minus 3. After this, what will happen? After this, what will happen? These traversals are done, but there is a traversal, the root node is left to be the ancestor, right? So let's say when you move back up, you come back here and 8, right? So now when your A is 8, and your what is the minimum element that you have seen up till here? B will be nothing but the minimum element that you have seen in the left subtree as well as the right subtree for a particular node, right? B is the minimum element in the left subtree as well as the right subtree. So the minimum element that I'm getting from the left subtree is nothing but 1, and the minimum element that I'm getting from the right subtree is nothing but 13, right? Not 13, because now the minimum element will be 10. The minimum element will be 10 because it will get updated to 10. So I can see the minimum among 1 and 10 is nothing but 1. So can I say that for A, that is when the ancestor is 8, that is the root node of the tree, then the minimum value for it, the B will be 1, right? So 8 minus 1 gives me a 7. So the difference here is 7. Right, so you can see that what is the maximum difference that you have seen up till here? You can see that there was a difference 7 that you have seen here. There was a difference 2 that you have seen here, right? Then you also saw a difference 6 minus 4, that is 2 here as well. Then you also saw a difference of minus 3 here in this case, right? For this node you saw a difference of minus 3. For this you saw A minus B, 14 minus 3, that was 1, right? So you can see what is the maximum. The maximum here is nothing but 7. So what should we do in this case? What should we do in this case? So this problem tells us that what you have to do to find the answer, what you have to do is the current node, the current node will return, right? You will traverse for a particular node, find the minimum descendant, find its minimum descendant, find the minimum descendant, right? Yeah, find the minimum descendant, that is find the minimum child. That is, if the given node is the ancestor, then you have to find the minimum descendant, right? The minimum value of B, that is minimum descendant, that is B, so that A minus B is maximum, right? A minus B is maximized, and you will always be having a variable result that will be storing the maximum difference that you have calculated up till now. This will be very clear to all of you, but the thing is that you will, for a particular given node A, that is, let's suppose that you are at a particular node A, let's suppose that you were at this node, right? So for this node you checked in its left subtree, which is the minimum value node that is there, and in its right subtree, which is the minimum value node that is there, and among those you compared that among those two which is the minimum, that is from here you were getting 1, and from this subtree, that is the right subtree, you were getting 10. So you compared and you saw that 1 was the minimum. That is why what you did was, 8 minus 1, that is 7, and you will do this for all the nodes recursively, that is using a DFS, and this way you will be checking, right? And in the end your resultant answer will be storing the maximum difference that you have seen up till now, and that will simply return the answer, right? So for each node you will be returning you will be having the minimum as a descendant that it has, and for each node you will be assuming it to be A, and if it has left subtree and right subtree exist, then for that you will be having a B which will be minimum, that is the descendant you will be choosing minimum. That is what I am saying. For each node you will be returning the minimum, and in that way A minus B will be calculated and you will be returning the maximum value of minimum. Is this much part clear to everyone? If this much part is clear to everyone, please quickly consider giving a +1 in the chat if this much part is clear. Is this much part clear to everyone? Just quickly let me know. Is this much part clear to everyone? Is this much part clear to everyone? I hope that it is, right? So what you will be doing is, let's say you have been given the int max difference. Let's say if this is the function and you have been given the node star root, right? You have been given the root of the tree. So what you will do is, first of all, you will have int answer that will be initialized to nothing but minus 1 e, let's say 9, that is the minus infinity, that is int underscore int minimum, you can see, right? Int minimum. After that, what you will be doing is you will be calling a dfs function. You will be calling a dfs function in which you will be passing the root, as well as you will be passing the answer, right? And in the end, simply you will return the answer, because your answer will store or you can say result, I've taken result in this case. So your result will simply be storing in the end the maximum answer that is possible up till there, right? This is your result. Now what will happen in this dfs function? This dfs function will be of int type, and in this there will be what? There will be node star root, that is the root of the current tree, right? Node star root, and you will be having int ampersand answer, because answer will be always getting updated, right? So what will happen if the root is equal to null? So if the root is null, then in that case what you will do? You will return maximum value, right? You will return int underscore maximum. Why? Because you know that this there is no node towards this root does not have any left or right. Okay, no, not that, but this node, the current node is null. Since the current node is null, so you'll not be considering it, right? So that is why you want your answer to be you want your from each, what is this dfs function returning? This dfs function is returning the minimum node for each, right? The minimum value, the minimum answer descendant for each particular current node. For each current node, this dfs function is returning the minimum node that I have seen up till now in the left subtree as well as the right subtree. So that is why I'll be returning int underscore maximum, indicating that there is no child node present, right? After this that for the current node, the child node doesn't exist, right? After that, let's say if this was 3 and this was 2 and this was not there, right? The left child was not there. So in that case you have to return infinity. Why? Because 3 minus infinity will give me a very negative answer, and this 3 minus 2 will give me 1, right? And I should be storing 1 in my answer. So my result is storing what? My result is storing nothing but the actual answer, right? But the overall answer, that is overall maximum, and I am going for the left and the right reversal, right? After this, what I'll do is I'll call in the left subtree, and what I'll get in from the left subtree, I'll call the dfs call, I'll call for the dfs, and from the left subtree I will see what is the minimum value that I get. Let me show you the code for more clarity, and then we can discuss about it instead of writing it. Okay, so what I'll be doing is I have int maximum function, and in this function I am having int result that is initialized to int min. That means initially I'll be since I have to maximize my resultant answer, that is the difference between a minus b, so that is why I'll be initializing it to int min, right? After that I'll be calling a dfs for root and result, and then I'll be returning the result. So what I'll be doing in this function is I'll be having the root and I'll be having ampersand results. That means my result, the changes in the result in this function will be updated every time, right? That is why I am passing it as call by reference. If the current root is null, then I'll be returning int underscore max. Then after that, what I'll be doing is I have to do this thing recursively, right? Why I have to do this recursively? I can see a lot of people are live, so if in case you are liking this, so please consider liking the video, and please comment down +1 quickly, so that I know that everything up till now is working. Okay, so I'll check that if the left subtree, I'll check what is the left subtree. I'll check the minimum element in the left subtree, right? The minimum element in the left subtree, and I'll check for the minimum element in the right subtree, because this dfs function will return the minimum node, right? The minimum node from the left and the right child, right? After that, what I'll be doing is I also want to maximize my answer, right? So int mx1 means the current difference, right? If let's say there is the current root, right? For the current root, I have to calculate the difference between the left child and the right child, and see the left maximum minimum value and the right minimum value, right? So what I'll be doing is root data, current root data minus left subtree, that is the left the minimum value that I'm getting from the left, that is minimum b value that I'm getting from the left. So a minus b for this and a minus b for the right, that is root data minus right subtree. So minimum value that I'm getting from the right subtree as well, I'll simply store them. And after that, what I'll do is I'll check that the current answer that I have calculated, the current a minus b that I have calculated for considering the left subtree, the current node a and the left with minimum value of b, the minimum value of b from the left subtree and the minimum value of b from the right subtree. So if that the answer that I have calculated, if it is the difference that I have calculated between a minus b, if it is bigger, greater, then in that case I'll be updating my result, otherwise my result will remain the same. And after that, since you know that my current DFS function is returning the minimum value, the minimum value node from the left subtree as well as the right subtree. So my left subtree for this node has the minimum value that I've seen up till here, right? The left subtree is having the minimum value that I've seen up till here, and my right subtree is the having the minimum value of b that I've seen in the right subtree, right? My right variable, right? After that, I'll simply return the minimum out of the current root data. Either my current root can be minimum, or either my left could be minimum, or my right could be minimum, right? So I'll be returning the minimum among those to the parent parent node, right? The parent node, the node that is for that I have called the recursion, right? So this was the code for the DFS part, right? After that, moving on to the BFS part. The BFS part, this question can also be implemented using BFS. Basically, you have to initialize your result as int mint, then you have to declare a queue that will be having pair of node and int, right? Node will be storing the current node and int will be storing the value. So you will be first of all pushing the current root and the root data. After that, what you will be doing is you will be iterating until the queue is empty, and you will be storing the current node, right? The current node will be q dot front, and after that you will be popping it out. So the first value p dot first, the current node dot first, will indicate the root, that is the current node, and int max answer is the for the current root, what is the maximum value, right? That is nothing but p dot second, right? Maximum answer, right? So I'll be checking if the right child exists, if the left child exists, then I'll be calculating the difference between the current node and the left data, right? After that, I'll check if the left data, if the difference that I have calculated now, if a minus b that I have calculated up till now is greater than the current, if the result that I have calculated overall, then I'll update my result. And if that if happens, then happens. Otherwise, I'll be pushing simply my current left node, and I'll be updating my maximum, right? A maximum difference that I've seen up till now, that I was doing in the DFS part as well. Similarly, I'll check if my right subtree, if the right child exists, then I'll calculate the difference between the current node and the right child. If the difference is greater, then I'll be storing that into my result. After that, I'll be simply pushing the right child and the maximum value, that is the maximum answer that is there up till here, and the result, right? So this is how I'll be doing it, and in the end I'll be returning the result. And this was the DFS part. So this question can be done in order of h time complexity and order of h space complexity, that is the height of the tree. So this was it from my side for the problem. If you have any doubt, please ask that in the comments. I'll be waiting for 1 more minute for everyone else to ask their doubts, and if there is no doubt, then I'll end this stream. So if there is any doubt, please mention that. Otherwise, please like the video and please give a +1 in the chat. Please like the video and please give a +1 in the chat if everything is clear to all of you. Is it clear to everyone? Is this question clear to everyone? Just quickly let me know in the comments. Is it clear to everyone? Just quickly give a +1 if everyone is clear with this approach. Chirag and Shubham and others. Okay, perfect. So this was it for today, and thanks a lot everyone for watching, and